Hopefully everyone can see my slides here. My name is Tim Appnel. I'm a product manager and evangelist from the Ansible team at Red Hat. I'm coming to you from Brooklyn, New York right now. I just wanted to talk to you about Kubernetes and Ansible and the ways that you can use the two together. I've been involved in Ansible project pretty much from the very earliest days as a contributor, as a user, then I was a customer. I then joined the original Ansible company as a consultant, and I've moved on to being a product manager as Ansible's been acquired by Red Hat. Now Red Hat's part of IBM. So I have a really good understanding of Ansible, and I've come into Kubernetes in the last couple of years and learning about that and bringing the two together. It's a topic that when I talk about it, I get a lot of puzzled looks from people when I begin talking about, why not use Ansible for this with Kubernetes? And so this is what's led to this presentation of talking about the ways that they can be used together in doing configuration management orchestration, and not just configuration management orchestration and DevOps, but also how it could apply to cloud native technologies like Kubernetes. So here to talk about these misconceptions, if you will, that are out there, because in all actuality, Ansible does fit naturally into a Kubernetes environment. They both make hard things easier through automation and orchestration. They're both very active projects, widely used open source projects that have been out there for years. In fact, I know in last year's Octoverse survey, Ansible was in the top 10 with Kubernetes. I think Ansible's been in that top 10 for the last few years. That's going to change for different reasons I won't touch in this presentation. But they also both have vibrant communities, and that's the important part here. In addition to all that, they both use YAML to describe the desired state of the world out there. And here's an example of what I mean. The YAML, on the left here, we have Kubernetes and a kubectl definition file for a configuration map that we would feed into it typically. On the right, we have an equivalent task inside of Ansible doing the exact same thing. If you compare what I have in red on the right side to what we have on black on the left side, they're almost identical. There's very little difference between the two in what you're doing and how you work with them together. One of the things I did leave in the Ansible example that I think is worth mentioning is the ability to do templates. So that's something that I know is being added to Kubernetes, but a year ago that you didn't have that, and Ansible brings a very robust templating engine and variable management and data management system that you can more dynamically create these definitions and apply them in different ways just by changing parameters. All right, so why Ansible? One of the biggest reasons you have this existing skills in this ecosystem out there. Ansible's been out for years. It's being used in all sorts of areas and domains, not just in the cloud native space, but in bare metal and networking and security, all sorts of ways. We're always amazed to see the ways that people are applying Ansible to different problem domains, different applications, different ways to automate things. So one of the advantages of using Ansible in working with Kubernetes is that it can support cloud native and traditional IT automation with one engine, with one simple language there. Another reason is the lower barrier to entry. Ansible doesn't require programming skills, and so therefore you can iterate faster. It's easier to maintain. It frees up your top engineering resources and allows junior people or people that aren't programmers to participate in helping automate your systems. As I already mentioned, it handles declarative state, and they both use YAML, and the templating that's built in, the templating of resources really helps things in what you can do. So one of the things I always like to mention, and this is something that when I do talk about Ansible and use with Kubernetes and really anything, and propose the idea of using it with cloud native or whatever problem domain, it comes back to this point to the extent that I jokingly created my own theorem here. And it's something I wanted you to keep in mind when you look at Ansible, when you look at automating something, is that every shell command and every UI interaction is an opportunity to automate. Meaning that if you're doing something where you are using a shell command or you are making a UI interaction, that's a chance for you to automate that so that it is more reliable, more repeatable, and easier to do the next time. So something to keep in mind as I walk through this. One of the things that we've been doing, and this is something that we just had Ansible Fest last week, I'm still recovering from it. We announced these things called content collections, which is allowing us to create these libraries, these packs of content that can be added to Ansible and updated independently. One of the things that we announced was a Kubernetes collection. So it is a supported collection by Red Hat that allows you to interact with core Kubernetes cluster resources. It also includes Helm 3, I should specify, the ability to automate Helm 3 tasks. So installing charts, managing the repos that you're pulling the charts from, adding plugins, things of that nature. Another thing that we have in the works right now for those of you who are using OpenShift, Red Hat's Kubernetes platform, we have a collection of content that is under development that brings those additional features that sit on top of Kubernetes in that area, and that one's community.okd. I should mention, so the community.core is currently known as community.kubernetes. We're in the process of renaming that. So the package is now called kubernetes.core, but the repo we haven't gotten through the name change. That's part of my work in the next week or two coming up. All right, so I'm going to talk about really top level, high level ways that you can apply Ansible to Kubernetes environments here. So these are the things I'm going to touch on very quickly because I only have a short amount of time here to work with. But just to give you an idea, sort of a taste of how you could apply Ansible to the Kubernetes space. And those areas are what we call last mile automation, the repeatable application and service deployments, the encoding human operational knowledge of how your applications get managed by a Kubernetes cluster, and then continuous deployment or GitOps, and taking that beyond just Kubernetes. So let's dive into some of those and start with the last mile automation. So when you're making or creating a Kubernetes cluster, it's more than just installing and getting the cluster itself to start up. There's a lot of things that you need to configure, set up, define within your cluster, and it's things like network configuration, firewalls, certificate management, monitoring, storage, hardening. So this is what we call the last mile. This is where, like I said, an installer, like OpenShift has a comprehensive installer, will get that cluster to start up initially, but then there's all this additional work you need to do to get that cluster to where it is useful. And this is where Ansible can be very helpful in that regard. And what it can also do is not only help you do that work, but do it repeatably, do it reliably, so that as you move from test to from dev to test to prod, or you have to set up multiple clusters in different data centers, things of that nature, you can do it repeatably. But you can also do it across you're not just related stuck in cloud native space. You can have it interact with a public cloud service like a hosted database, or you can have it talk to an application that's in a traditional, I'll call bare metal setup, or you can have it talk to network equipment, your network infrastructure, your DNS, your switches, things of that nature. So that's last mile automation. So there's those. So next up, we have repeatable application and service deployments. So this is something I see often, and it sort of bothers me a little bit. Excuse me. You know, one of the things when I came into working with Kubernetes is that I would go to sit down to try to work with something. I'd be given this really long list of kube control, Helm, OC, sed commands, sometimes instructions to take a file, copy it, and make manual edits to it. And it kind of threw me back to and reminded me of the days of sysadmin run books in the 1990s. And being an automation guy and having worked with Ansible so much, this really bothered me. And this is an area that Ansible can really help. And this is an area where I just sit there and say, oh, I wish they just wrote a playbook for this, because I've just spent an hour trying to install this app, and all I want to do is try out the app or run through a lab or something like that to get familiar with whatever it is. And I spend so much time on the setup instead. So this is an area that Ansible can really help, because it can combine the parameters, the variables with the templates that we've already talked about, the Jinja 2 templates, and pull them together in a playbook, run through the Ansible engine, and then it can deploy it to whatever cluster I point it to. And that can also be done repeatably, because once I get it straight for maybe my dev environment, I can then pass that on to the QA team, who can repeat that same setup in their testing, and then it can be rolled out to multiple clusters that I may have in production that are in different data centers across the world. Okay, so another area that Ansible can help is encoding the human operational knowledge for managing a Kubernetes app, and specifically that is operators. So operators is something that came out of CoreOS, which is now part of Red Hat. And the idea of an operator is to simplify the management of complex applications on Kubernetes. Kubernetes has a lot of its own built-in operational models to help you get things done, and that's great. But it also has to treat everything in a very, very generic, basic way. And so that's great if it is a stateless application or service. But when you have something that has state, for example, or has complex handling, Kubernetes doesn't know that. It doesn't know how to manage your application at that point. And you can try to architect some of that out of your application, but you can't always do that. And that's where operators come in. They allow you to give Kubernetes that extra intelligence, that extra smarts in how to manage your application. So that's where it encodes this human operational knowledge, and it can define and handle the patching, the upgrade, the recovery, things of that nature. But it does it in a container, in a Kubernetes native way, and it runs on the cluster itself. So it's this specific controller that's purpose-built for your application that knows how to do all the management, the full lifecycle management of your application, because you have developed that for your specific application. So in all actuality, an operator is actually a pattern of a certain type of controller. That controller is watching events, it's running on the cluster itself, so it can react within a split second versus where you would have to more traditionally monitor something and an alarm would go off and a human would have to get involved, log in, maybe in the middle of the night to have to take corrective actions. An operator is sitting on the cluster itself, it's watching for events, and then when something changes, it does what's called a reconcile. And a reconcile is where it says, this is the desired state I'm supposed to be in, and this is the current state the cluster is actually in. And the reconcile is the work to bring the desired state, or I should say the current state, in line with the desired state, whatever that takes. And that's the logic of the operator. So the way where Ansible works into this is that there's this operator SDK that's out there, the operator framework that's now part of the CNCF that Red Hat has donated to that group. And there are three means of writing an operator using Go, which is the way that the Kubernetes itself is written in, using Helm, and then the third supported way is using Ansible. So what we're looking at here is a diagram for how Ansible operators would work. So you have this binary, this generic binary that you get for free using the the Ansible operator SDK, and you create a small YAML file, which is called a watch file, and that is mapping the resource on the Kubernetes cluster you want to watch. And when a state change happens to that resource, what included playbook or role you want it to run, and then that does the reconcile for you. So you don't have to worry about knowing Go or understanding a lot of the intricacies of the Kubernetes API to write something properly. You're just focused on creating that watch file that maps what you want to do to a playbook or a role that you wrote. So you only need to know Ansible in order to create this type of an operator. All right, so that here's an example of one that we've demoed before. So McRouter is sits in front of Memcache, and it works as like a smart proxy, and it adds a lot more functionality to what you can do with Memcache. And so what you need an operator for is that this McRouter needs to know what is in its pool of Memcache servers in this case. So as a server may drop off, its configuration needs to be updated, and as more are added, there's a scaling event that you need more capacity and you add more. It knows that it knows how to do that, and it knows how to update the configuration, that being the operator that we've written inside of Ansible. So that's just a quick idea of how you would apply or why you would need an operator, is that the system Kubernetes itself doesn't know that when it has to maybe replace a Memcache node that's gone bad, or some type of event happened that it needs to scale up, how to do that and how to update the configuration of the McRouter proxy server service that's running on your cluster. Okay, so moving right along, because I want to give some time for Q&A. The last area I want to touch on is continuous deployment, or more specifically GitOps, but also GitOps beyond Kubernetes here. So this is a typical GitOps workflow. Developers are doing their usual process of putting their code inside of Git, and it runs through CI. Once they're ready and all that passes and they're ready to make a release, an artifact is pushed to a registry or a repo or whatever it is that you're using. And then, but in a GitOps space, you have your configurations done in a declarative way, stored in Git itself. Also, that is being used as a single source of truth by your operations team, or maybe it's still part of your dev team, depending how you're set up. And then those two are pulled together and pushed out into conventionally Kubernetes itself. Now, with Ansible, you get a lot of other options, and this diagram here shows a little bit of what I'm getting at. The whole CI development chain still works the same. Git to CI into your registry, but when you use Ansible, there's some unique advantages to your GitOps pipeline that you've created, because now you can not only can you push out to Kubernetes, but you can also apply these GitOps pipelines workflows to public cloud, AWS, Azure, even VMware, but also network infrastructure, and really anything else that Ansible can work with and orchestrate there. So, the advantages of Ansible is that it has these flexible capabilities to extend GitOps to all existing IT infrastructure. So it gives you that flexibility and freedom to do the deploy, the manage, the automate of multiple environments. Another thing, if you get to dive into GitOps a little deeper, is that most of them work off of agents running on the cluster itself. Well, Ansible's well known for being agentless, and in this case, this gives us the flexibility to talk to multiple environments from this one control plane. You don't have to go out to each thing that you're managing and install these agents first to do the actual work. You can all do it from this centralized place. So there's a lot more, we think, flexibility and freedom. And like I said, it gives you that added benefit of working in existing IT infrastructures into a GitOps pipeline. All right, so that was a very top line review of the way that you can use Ansible and in all these different ways. And like I said, these are just some of the most common ways. It's really, you know, it's you're not limited to just those. There, it can do virtually anything you can think of doing with kubectl or the K8s API. Ansible has the capabilities of doing some form of automation to help you out. So if you're interested in knowing more, I know I had to really cut across a lot of material very quickly here. These are some resources, different articles, blog posts, and things to check out. I will come back to or leave this screen up for a minute here. The slides will be available later, I'm sure, through the OSAD conference site. And thank you very much for listening. If anyone has any questions, fire away.